Hello everyone, so this is the direct and partial variation lesson. So I'll just go through this on here. You can take your notes and just remember, it's a video. You can pause at any point, so I might be going through things a little quicker just because I know you'll be able to pause it. Okay, so first of all, we're going through direct and partial variations. So you should, by the end of this lesson, be able to identify and describe direct and partial variations. So what are they? And solve word problems with linear relations. So that is what we are heading for. Okay, before we get there, let's just take a look at this minus on. So you might have seen a graph like this. This was part of that little investigation we did with Desmos. What's the difference between these two? What's the same? Okay, so first of all, you might see the differences. Well, they're in totally different spots. And if we look at the y-axis, they're crossing in totally different spots. You can also see in their equations, they're both 2x's, so they're parallel. But the one's missing a little plus or minus part, whereas the other one has a +5. And those are the main things to look at. So let's continue on from there. So first, let's take a look at one like the first one there where it was just like 2x. And what we can say about a relationship or like a graph like that is a direct variation. So a direct variation is a relationship between variables in which one variable is basically a constant multiple of the other. Or we could say y is equal to something times x. And generally that something, we label that as the letter m. And that's just convention. M is that letter that goes before x. And that's what direct variation is. So that letter m, or that something that we said, that's sometimes called the constant of variation. And you can figure out the constant of variation by, if you're given, let's say, an actual table of values, so we have one here on the right, just divide your y value by x. And then that will give you the constant of variation. So for example, in this one, well, you might look at the first row and be like, well, 0 divided by 0. What does that give us? Doesn't work out. But yeah, that's because we can't divide by 0. But if you take a look at any other point in this table of values, so let's take a look at 20 and 2. So your y value is 20, x value is 2, 20 divided by 2 equals 10. So over here we could say something equals 10. We could have actually written 20 divided by 2 over there. But that's the idea there. All right, let's take a look at another. And for these ones again, pause it, try it for yourself, and I'll go through the answer. All right, so for this one, again, remember, what's the something? As in the constant of variation, not the constant of variation. It is the constant of variation. I was confusing myself there. Sorry about that. Constant of variation. So it's y divided by x, which is simply just, you can take a look at the first one, 3 divided by 1, which is just 3. And generally that's actually a good way of quickly finding it for the easiest, let's say, division. Just look at your first point. That's not 0, 0. Okay, take a moment, try that for yourself. All right, so what we can do here, again, the constant of variation is y over x. So if we look at the first one, this point here, -2 over 1, which is just -2. So that is your something that you're multiplying by x. All right. Now we actually want the direct variation equation for the following relationship. So remember, the equation, it looks like something in the form y equals m times x. So what we need to do is we need to figure out, well, what is this m value? So what is that? So we'll do that off to the side here. So just like we did in the other examples, take a look at the table. We'll take a look at 5 and 1, so to y divided by x. That does not look like what it's supposed to look like. Let's erase that. 5 divided by x, which is 1, which is just 5. All right, and for this one, then what you do for the actual equation, you just write it as y equals 5 times x. And there you have an equation that corresponds to that table of values. One other thing you might have noticed, and I'm just going to point out right now, is take a look at what's happening as you go up this table of values. Look what we did. We just added 5, and that's actually our constant of variation. From 5 to 10, well, look at that. It's another 5. 10 to 15, another 5. That's not just a coincidence. There is something going on there that relates to the constant of variation. But first and foremost, just make sure you know how to find the constant of variation using this method and being able to use that to find our equation there. Let's try again. So again, pause it for yourself, make the equation, and I'll go through it at this time. So again, we want an equation of the form y equals mx. So m, what is that going to be equal to? Let's just look at the first one. So y is 1.5, m is 1. So you could do 1.5 over 1, or I mean just like write it as 1.5. But let's take a look at another one, because we could write this in another way. So, and you'll see that it's equivalent. But let's take a look at the second point, and you'll see that y is 3 and x is 2. So you could also just write this as 3 over 2, because that's like the most reduced version of that fraction, which is 1.5. And so you could write your equation as either 1.5x or y equals 3 over 2x. And yeah, sometimes it's nicer just to have it in a fraction form, just because then when we're manipulating the equation, we can do things like clear the fraction and such. So that's why sometimes you might see it as 3 over 2 instead of 1.5. All right, so what are some characteristics of direct variation? So you can definitely, get this written down as a point in your notes. So first of all, direct variation relationships are, well, they are definitely linear. So that is the first thing. And you can see those are two graphs of direct variation. So you can see they both create lines. Next, characteristics of direct variation. So the next one, the direct variation relationships all pass through the origin. So remember, the origin is the point 0, 0. So down in the bottom left corner, and look at those two examples, they both do. And that's true of all direct variation relationships. So again, you can include that as a point in your notes. All right, so here's sort of the second half of the note. We're now going to look at partial variation. This is where things get a little more complicated, and that's because, well, what is a partial variation? Well, it's a relationship between two variables in which one variable is a constant multiple of the other plus some constant. So that's the key difference, is this plus some constant part. And so you can also think of it as a relationship between two variables that includes a fixed amount. And if you think back to that Desmos investigation, we had that Desmos investigation where we had like the red boxes and the blue ones, and you had that pattern where it was like 2 blue boxes, then that became 4 in the next one, but the number of red ones stayed the same. So the red boxes would have been, let's say, your constant, and the something that was changing was like the number of blue boxes. And that's what a partial variation is. So you have sort of two parts. You have your something and you have your constant. All right, so we can think of it as two different parts, as I just said. The value next to the x, we call that m. We can think of that as the variable part. So that's the part that, because you're multiplying it by x, which changes, that's going to be giving you new numbers each time. However, the fixed part, the b, that stays the same. So you'll always be adding the same number, no matter, let's say, what position of a pattern you're in or what value of x you use. So how do we find that fixed part? So what we can do to actually find that fixed part is when x is equal to 0, so when you're at this point in the table of values, this little number here, the y, that is actually your fixed part. So it's just 1. So when x is equal to 0, then y is equal to your b value. So y is 1, so b is equal to 1. And that's going to be a very handy fact as we go through these kinds of questions. All right, let's take a look at another one. So try this one out on your own first. Okay, and so remember that when x is equal to 0, y equals b, so we'll just use that. So that means, well, b is actually just equal to 6, because y is 6 at x equal to 0. All right, here we have another one. Okay, so again, take a look at your first value, and that is your b value. And just always be careful, actually, with your table of values. You'll see in both of these examples, your table of values started at 0, but I could just as easily, let's say, start a table of values at, -2, -1, and then get to 0. And so in that case, let's see if this going on, still when x is equal to 0. And so you'd have a b value of 1, even though it's not the first value in your table of values. All right, so here we now want to write the partial variation equation for the following table. Okay, so we know what we want to do is we want to get it into a form y equals mx plus b. And we've just been working with that b value, so we know the b value is just the one that's next to x equal to 0. So it's that 10 there, so b is equal to 10. Okay, so let's just plug that in. So right now we have y equals mx plus 10. We still need to find out, well, what is this m value? How do we figure that out? Because before what we just did was we just did y divided by x, and that worked out nicely. Now, can we actually do that? Well, we can't actually do that in this case. So m is unknown. What we can do is that m value is what causes, in a sense, our equation to change. So that causes these differences in the y part of the table. So let's say when we're going from 10 to 12, we're adding 2. When we're going from 12 to 14, we're adding 2. When we're going from 14 to 16, we're adding 2. So that amount that's changing by the same each time as you go down the table, that is actually our m value. So just like how I looked at before when we had an m value of 5 in that direct variation case, we saw it went up by 5 each time. Well, even in partial variation, the amount it goes up by each time will be your m value. So we can say m is equal to 2. So you can say y equals 2x plus 10. And that is now your equation based off that table of values. Okay, so again, let's look at some characteristics of partial variation. So there's a couple of graphs. Partial variation relationships are, again, linear. So you can get that down in your notes as well. And another characteristic. So partial variation relationships all pass through the origin. Well, let's take a look at this. The origin is way down here. This line is not going through the origin. Same with this other line. So no, this is actually not true. Partial variation relationships do not have to go through the origin. So just be careful with that. That's only true of a direct relation. Okay, so now that we've gone through partial and direct variation, let's just take a look at some word problems that would involve these concepts. So we've got Patrick. He's decided to, I guess he's a taxi cab driver now apparently. And he's charging $2.50 plus 50 cents or $0.5 per kilometer for each trip. And the graph displays the relationship between the distance and the cost. So we want to write the partial variation equation. So we want to write something like y equals mx plus b. Okay, so now we need to look at things a little differently. So there's two ways we could do this. We could actually convert this into a table of values. So just directly write down x and y and then take a look at our points. So like there we have an x point of 0 and we can see that it's, well, 2.5. The next one we have an x point of 1 and it's at 3. And just keep doing that. So you can see at 2 we're at 3.5 and at 3 we're at 4.0. All right, and then we could use our table. So we know from what we said before, the b value is 2.5. And so we can say b equals 2.5 based off of that. And then how much does it change each time we go down? Well, each time we're adding 0.5. Since we're adding 0.5, that becomes our m value. And so overall, the equation would be y equals 0.5x, because that's our m, plus 2.5. And there we have the equation. One thing you might notice is actually, if we take a look back at the word problem, you can see that his initial charge was $2.50. That corresponds directly to actually the b value. So what you start with, which is sometimes actually known as the y-intercept, that ends up being your b value. And then what happens is you're adding 50 cents per kilometer. Well, that's your regular amount that it's going up by. And so that also corresponds to your m value. And so you have actually that correspondence between the words and the equation directly. So you could go through it that way as well too. All right, let's take another look at another question. So Emma, she's got a job, she's got a boss, and her boss is giving her an option of how she collects her paycheck at her new job. Cool. So she can either earn a commission of 50% of her sales each week, or she earns a guaranteed $400 and a commission of 10% of her sales each week. Okay, so let's just get this written down into words. Or not into words, into equations. So option 1 is what we'll start with. Okay. So first of all, it says she earns a commission of 50% of her sales each week. So one way of thinking of 50% is, well, 0.5, you're multiplying something by 0.5. And it's not like she has any starting point. So her starting point would be like $0. So this is actually a direct variation. So it's going to be something like ymx. And well, that 50% is, let's say, the proportion of what she's making. So we could just write this as y equal to 0.5x. So that's the first option. Option 2. So option 2 has two parts. So it's got, the something you're multiplying by and the fixed part. So the fixed part is, well, the thing that stays the same no matter what, that's the $400. So that we can think of as our b value. Because remember, we're doing y equals mx plus b. Let's just write that off to the side. So our b value is 400. And the variation, that comes in the form of the 10% of her sales. So m would be the 10% part, so 0.1, and then you'll do like m times x. So you'll have something like 0.1 times x plus the 400 you start with. And there you have your two options. Yeah, so when you're looking at trying to translate words into equations, first of all, see, is there any sort of fixed amount that we're earning or getting? That will become something like a b value or a y-intercept. We can also think of it as. If there's something where it says like we're earning based off of some other amount, so like earning 50% based off our sales, earning 10% based off our sales, that's sort of indicating that that would be your variable part, so the m value, or the constant of variation in that case there. Okay, so now let's look at part 2. So if she sells $900, basically, which of the two options is the best? So let me just rewrite the two equations. So we had y equals 0.5x and y equals 0.1x plus 400. So now you just have to go through substituting 900 into each. So I'll write that down, sub $900 into each. Okay, so 0.5x becomes 0.5 times 900. And so if she did that option, she will get $450. All right, what about this other option where she's getting 10%, but she starts off with 400? Well, 0.1 times 900 plus 400. If you do this calculation, 0.1 times 900 becomes 90 plus 400. And so in the end, y will be 490, and that would be dollars. So there you have it. The second option is definitely the better option because it's the higher paycheck. And as usual, it's a word problem, so throw on a therefore statement. So therefore, option 2 is the higher paycheck. At $490. Okay, and that's everything for this lesson. So yeah, just make sure, first of all, know how to find your values within partial and direct variation. So in y equals mx, how do you find that value of m? Or if it's y equals mx plus b, how do you find the value of b and m? And you can use the table of values for that. But it's also good to be able to translate word problems and be able to get these equations as well, as we just did in these last two examples. So that's everything. So go ahead, try out the practice problems, and good luck with those.